Thanks everyone for joining. Welcome to our talk. We're going to talk about application performance metrics at Netflix and how we enable smooth and consistent user behavior all throughout the world. First, I'd like to invite Jitendra to give you a little bit of context about Netflix and how we operate in our environment.
Check. Does it work? It does work. Welcome and good morning to all of you. I hope you chose this session wisely. So first and foremost, as a leader and a hiring manager at Netflix, I want to acknowledge that diversity in tech in our workforce remains a problem at large. We all have to do our best to improve diversity. And I am so proud to work at Netflix because at Netflix, this has become one of the topmost goals. So I want to call to an action that let's do our part in improving diversity in our workforce. Thank you. So now from diversity in workforce, let's talk about the diversity of a problem. I think you all know from the title of the session was very clear that Netflix has over 130 million subscribers spread across the globe. And that actually creates a very interesting problem for us. Like, how do we measure app performance? How do you actually scale this problem? And from subscriber base, if you jump to the ecosystem of devices that we have, so starting from the left, Netflix is everywhere. We're on streaming media players. We're on smart TVs. We are on game consoles, set-top boxes, Blu-ray players, smartphones, PCs, and laptops. So we have a very diverse device landscape. And to just go into one device category, these are the number of smart TVs on which Netflix is powered. And I'm just giving a sliver of the complexity in our device landscape. So we have a very diverse device ecosystem. So take a look at the global subscriber base. Let's go. Let's take a look at the global subscriber base. Then, and you can imagine that the subscribers across the globe, they all have a very different behavior. They consume content very uniquely from all of us. Marry that with complex device ecosystem. Now, because we're global, we also have to address the ISP issues. We also have to understand when we build our cloud infrastructure, what's the availability of at-scale cloud infrastructure across the globe? So that adds another dimension of complexity to our problem statement. Right? So with that, let me now talk to you about how Netflix culture facilitates the innovation which allows us to address the diversity or the complexity of scale that we handle. So first and foremost, this is freedom and responsibility is one of the key traits of Netflix culture. We truly cherish it. We actually guard it very well. The reason for that is that without freedom and responsibility, we will not be able to make distributed decisions. So freedom and responsibility allows us to do distributed decision making, which allows teams to move very fast. It also allows us to scale complexity. From the previous slides, it was very clear to you is that the problem we have in front of us is very complex. It needs a very different mindset to address that problem. But at the end, if you look at the responsibility piece in freedom and responsibility, it's like ultimately we all move fast. We're all trying to address problems. But the responsibility piece is that let's do what's right for Netflix. It's not about the team. It's not about the individual. It's what's right for Netflix. And that's another piece of freedom and responsibility we really cherish. Related to freedom and responsibility is another thing is context, not control. It's very clear from the phrase itself. It's like we don't believe in top-down decision making. We don't believe in centralized decision making. So with context, not control, we facilitate information sharing, and it's all about let's share as much context with all the teams that are working together to address this problem. so that each and every one at Netflix is empowered to make independent decisions. Freedom, responsibility, context, not control. And the third piece of our culture I'm going to talk about is like highly aligned and loosely coupled. It might take a second to understand that, but it's all about we all have shared strategy. We share same common goals. But you can imagine we have a very diverse device landscape. So you saw smart TVs, you have mobile phones, you have browser application. So you can imagine that there might be lots of teams that are trying to address the application performance to improve quality of experience. They all have same goal. It's like Netflix should work as soon as someone opens the application without any delay. That's a common goal. And each team is now empowered to go address that independently. So they all have independent execution plans. So freedom and responsibility, context, not control, highly aligned and loosely coupled. These three key traits allow us at Netflix to address these kinds of complex problems. With that, let me introduce, this is about how we have built global cloud infrastructure. Let me introduce our team. Vivek and I are part of People Security and Info Data Engineering team. Our mission is very simple. We actually look at cloud infrastructure data and we improve infrastructure dimensions such as its operations, performance, security, reliability, and availability. There are I have listed 3 top problems that we are tackling. Vivek is going to talk to you about the application quality of experience. Asset inventory is another key problem that we're tackling, and anomaly detection to tackle security problems. With that, I would pass it on to Vivek.
Thanks, Jitinder. So, quick show of hands. Who all here is a Netflix member? Show of hands. Who all watch Netflix in their living room, somewhat like this? Me, right? What about on your mobile devices? Anyone watch on their mobile devices while they're commuting in the airplane? What about here? This is actually a field in Kazakhstan. Anyone here from Kazakhstan? No. This is actually one of the engineers that I work with. He was on vacation in Kazakhstan. This was a few years back. And he was determined to see if he can make Netflix work out in this field in Kazakhstan. This is before we had rolled out to that country. And he did make it work, as you can see. He was watching Ip Man for some reason. But it didn't work really well, to be honest, because we hadn't thought about performance. We hadn't thought about quality of experience on a global scale. But this was kind of the first step towards what I'm going to tell you about next, which is Netflix everywhere. So in January of 2016, at the Consumer Electronics Show in Las Vegas, our CEO, Reed Hastings, got up on stage. He had that slide up there, and he said that we're going to roll out Netflix to 130 countries additionally from what we already had. Basically, everyone in the world could go to Netflix.com on that day and sign up for an account and start streaming movies and TV shows. That was quite a bold statement. It surprised a lot of people. We didn't honestly plan too much ahead of time. We kind of had infrastructure in place. And I'll talk about the things that we had done to kind of help us scale. But this was a big announcement and very exciting for all of us at Netflix and obviously our members worldwide. At that time, we had about 60 million subscribers. We've obviously grown since then. Streaming hours have increased, and obviously the device variety that Jitendra talked about has also exploded. So he talked about, this is a quote from the keynote. He talked about providing access to our users wherever they are. So not only in terms of countries, but also if you're on a mobile device, commuting on a train in Tokyo, or you're in your living room in India, or you're watching on a mobile device somewhere else in the world. We want Netflix to work everywhere. We want it to work fast and smooth as well. We want to give a consistent experience. Whenever, that's pretty straightforward. Like you can log on anytime. However, there's a dimension here that most people tend to watch Netflix at prime time, let's say. So you're going to have a lot different characteristics in terms of usage during prime time as opposed to middle of the day. And that varies by country. It's kind of surprising, the patterns that we see in different countries, how people consume Netflix. And then he said, we are going to support whatever device you have. Bring whatever device you have, we'll support it. Jitendra already touched on this, and I'll give you a little bit more idea of what kind of devices we support. And then finally, he said, no more waiting. So no one likes waiting on a loading screen endlessly, right? And this was the bold statement. This was the statement that threw the challenge down to us, saying that we need to make Netflix fast. So this was the theme. We wanted to make Netflix scalable. We wanted to make Netflix smooth, consistent for anyone, anywhere in the world. And this was a big challenge. So where do we start? How do you even figure out that someone's having a bad Netflix experience? Well, in data, you must have heard this before, measure everything, right? Start with measuring everything. That's a very good place to start. Think about instrumentation before you embark on this journey. Instrument everything. Now, if you instrument everything and you have a global user base and you scale up to 135 million members, the current volume of data that we get from our client applications is about 200 billion data points per day. It's closing in on a petabyte of data, so it's a lot of data every day. As I said, we have a lot of members spread across the world. We are actually more than 50% outside the US now, so most of our members are outside the US. And as I said, 200 countries. So it's a very diverse ecosystem. We have almost 350 million devices, unique devices streaming every day. Actually, the number is much higher than this, but it's in the hundreds of millions of devices per day. So it's a really diverse ecosystem. Measuring everything is good, but really what we found was that measuring everything consistently was the real key. You can't just go and measure something on TV one way and on your mobile device another way. The more consistency that you bring into your measurement, the better you're going to be able to analyze that data in the future. So what's the goal of measuring everything? Like, what are we trying to measure? What are we really talking about? So I'm going to give you an example. I'm going to show you a little bit of a clip where it'll show you an app launch sequence on a TV device. And this is really like a best case scenario that you're going to see. But you're going to see where it goes from there. So here you have it. The app has launched. Person selects what he was last watching, which happens to be Lost in Space. The video buffers, and it's on. So it's about 7 seconds from the time you launch the app until you start playing the video. So that's pretty slick. That's pretty good. But actually, if you take a look under the covers, a lot of things are happening. A lot of things are happening behind the scenes. The 7 seconds looks pretty fast, but we are touching hundreds of microservices in the back to make that happen in those 7 seconds. At a high level, you have launched the app, so the app has gone from a cold start into running state. You've logged in your user, you've checked whether the user's credentials still exist, whether this is a real user and they are in the right country and they have all the correct account setup that they want, that's needed. Then you load the home page, so you see the list of movies, you see the continue watching row, everything that's personalized for the user, we load that. The user clicked on Lost in Space there. We'd load the movie details for that. Then he clicks play. After that, we buffer the video, and we start playing. So a lot of things happening in the background, right? And this is what we are really trying to measure. We're trying to measure all these pieces and how they fit together to combine and give this user that experience that he's seeing. And we want to measure each of these independently, as well as also think about it from a user perspective, that for me, I don't care that there are 100 services that you're calling. I just care about getting to my movie quickly. And that's also what we want to measure. So you start with all these things in mind, and you come to the project that we started back then, which we called it application performance metrics. Um, so we had metrics like application launch times, play delays, so from the time you click play until the time the video starts playing, details page time. Sometimes you're hovering over a movie, the details just take time to come up, and you may kind of lose interest in it, and you may move forward if you don't see it in time. Now these metrics are great, but we also need to slice them by various dimensions for it to be useful. So we have obviously geo dimensions like country, which country is getting better performance. We obviously have it at a much granular level as well. Network is a big component in application performance. What kind of network are you on? Are you on a mobile network, or are you on Wi-Fi? And what are the characteristics of that network generally? Obviously, the device plays a big role in this. If you're on a low-powered Android device, there's very limited CPU and memory that we have to work with, so we have to be very judicious about how we manage resources on that kind of device versus, let's say, an iPhone 10, which has a lot of power behind it. And then we also do a lot of A/B testing around this, so all of our metrics, our engineers can see them through various A/B tests. So they can see whether, if they run a test specifically for testing application performance, they can kind of see the result of it as soon as they run the test. So on the left side there, you see this is actually a graph of app launch times by country. And you'll be surprised if I were able to reveal the numbers. I can't, but you'll be surprised by some of the numbers there. And the United States is actually somewhere in the middle over there. It's not among the best, actually. So how do we do all this? Obviously, we need a lot of data. We're collecting all that data. We want to make sure that it's consistent. We want to make sure it's clean. We want to make sure that we know what we're logging. So we start on this data journey. So I'm going to take you on this data journey. But before we get going, really this slide is meant to call attention to the fact that this is really a team effort. There's a lot of different teams involved in this. There are obviously all the 4 different platforms, the TV platform, iOS, Android, as well as web for laptops. So there's a lot of people involved, and getting the key people involved and aligned with yourself is really what set us up for success in the beginning. So before we actually dive into the data, what really helped us was defining a schema. And I can't stress enough on this, schema is really important. Thinking about your schema ahead of time gives you leverage later down the line to understand what your data looks like. If you go fully schema-less, I think there are challenges that you face down the line when you are scaling up and supporting more and more types of devices and more and more types of experiences. So keeping an eye on your schema is very important. And that doesn't mean that you need to be very stringent about it. You can define high-level concepts. So like we went in and defined high-level concepts where we said, let's log things that people are doing in the application. Let's look at things like start play action. Things like whether the action failed or the session that was started by the user ended or not. So we have these conceptual kind of sessions which record what's happening in the app. And then there are end states for those. So there's a conceptual kind of structure around the way we want to log. And this is consistent across all the device platforms. So TV does it the same way, Android does it the same way, iOS does it the same way. Obviously, there are nuances between the different platforms, so we support that with logging. But in general, we try to be very, very consistent as much as possible. And then finally, the data itself can look something like this. Like there's obviously a JSON payload that the client sends over. Each of these sessions can be represented in a JSON format. And then you have various fields that represent the things that you want to log. So really, schema is very important to start off with. So with that, let me dive into the architecture a little bit. So obviously, you have the devices. The devices, as soon as the user starts interacting with it, they start sending data back to the Netflix services. So we have a bunch of edge services that are designed to receive this data. You can think of them as REST endpoints. I'm not going to dive into too much detail, but there is a huge distributed system behind this, a globally distributed system which receives this data. From those edge services, we push that data through Kafka. So we stream that data into Kafka. It's not just Kafka. We have our own kind of implementation within Netflix called Keystone, which has a fronting Kafka as well as a router, and then we can pipe the data into various sinks, be it S3, be it something like another stream, let's say, or in our case, we pipe it into Flink. So from Kafka, the data goes into Flink, where we do a number of pre-work, so to speak, to make the data ready for analysis. You saw that JSON payload. We extract some of the fields from there and make it top-level fields. We do a little bit of massaging in terms of timestamps. We enrich a little bit of geo data from the IP addresses, things like that. So all that is happening in real time in Flink. From there, we go into Spark. This is where the real analytics happen. And this is what I'm going to dive into in a lot more detail now. And then from Spark, when we generate all these metrics, we need to analyze them. We have a lot of data, so we need to analyze them, and we need to give people dashboarding abilities. So we put it into a system called Druid. Druid really gives you the capability to run sub-second queries on large data sets, and also do custom aggregations, and that's really the key for us, at least. And I'll dive into the custom aggregations towards the end as well. So this is really our architecture at a high level, simplified. I'm going to talk about the left side, or the left side of the right side for you guys. I'm going to talk about that in a bit more detail here. So that's the piece where we are generating the metrics, right? So any Spark application, you're going to take this data and you're going to massage it. You're going to filter it first. You're going to project the columns out that you want. So in the Flink stage, we had already extracted some columns, but they're not all the columns. They are really commonly used columns. For performance metrics, we may want to surface some more columns up to the top level. So we project those columns out. You enrich it with other data sets that you need to enrich it with, like user data, geo data, the A/B test that the user is running right now, any kind of enrichment that you want to do. And then finally, you calculate the metrics. And that's really the meat of your Apache Spark application. So let's talk a little bit about the filter stage. So the source data is about 200 billion rows, like I said, petabyte of data. You don't want to work with it. You want to filter it out as much as possible immediately. So you have your filter predicates, like what event types are you interested in. So we filter out on a specific set of event types. We know that some things will not help us, like box art was presented to the user. That's a very high volume kind of log. We don't really care about that from a performance perspective. So you only care about certain types of events, so let's filter those out. Also, the date range is a very important thing. You want to pick a date range that you can filter out, let's say a daily or an hourly range that you want to filter out, because there's also late arriving data that you have to take care of. So doing this on a very small window can sometimes cause you to miss out on a lot of late arriving data, and that has its own challenges. So picking a good date range is a good thing to kind of consider in the beginning. Drop the columns that you don't kind of need. There's a lot of raw data that comes along with this, and most of the times in the in the projection stage, you kind of pick the data that you want, and you can drop the rest of the data. So you're basically paring down that large data set and making it manageable to work with down the line. Important thing with this is that the data comes in a large number of files. So it's a huge data set. There are hundreds of thousands of files. And when you run these filters, the output of this stage can be really skewed. And that's something to keep an eye on down the line. If you start with skewed input to your other stages, you're going to have challenges going forward with your Spark application. So with that, in the next stage, you're going to project and enrich your data set. You extract additional fields. You typically use UDFs, so we have UDFs for all extraction of data that we do, and those are kind of universally available to everyone within Netflix. And then obviously you want to put user metadata, like I said, geolocation, device metadata. You have all these side inputs that you want to enrich your data with. I'd recommend using broadcast joins wherever possible for this, because usually these data sets are smaller in nature, and you want to aggressively use broadcast wherever possible. And Spark allows you to set the broadcast threshold. And I would say, if you're working with such large data sets, be very aggressive with your broadcast thresholds. Use the memory that you have at hand. From there, the next stage is calculating the metrics. So as you see the schema up there, there are a number of different events that can make up a metric. So you can have 5 events that make up one app launch event. So you're going to have to do a lot of joins here in this stage. And this is where it really gets hairy. So you've really prepared your data during projection. You may have even done some repartitioning, which is usually a bad thing in Spark, but we've found it that taking the hit of repartitioning sometimes is good for performance for the next stages. So you repartition to avoid that kind of skew when you're joining these large data sets. Sometimes you may want to sort. If you know that you're going to join on a certain column and your source data set is not sorted, you can kind of sort the data ahead of time, and that'll kind of force a repartition and distribute your data evenly. One thing to keep in mind, which hit us pretty hard, was that your join key should not be null. If you have null join keys, you're going to have a real big explosion of cardinality, and you're going to have a lot of issues with your Spark jobs. You'll have long-running executors because they will all kind of accumulate in one or a set of executors. So be sure to filter those things out. Make sure your join keys are clean and pristine. So all of this takes a lot of tuning to succeed. And I'm going to share a little bit about what kind of tuning we've done and what are the things that help us out, which stand out for us. So who knows about the 3 M's of Spark tuning? Anyone? No one? I call this the shotgun approach. It's basically memory, memory, and more memory, right? Right? Everyone's done this. I've done this. When your Spark job fails, increase memory, retry, right? Everyone does this at some point. But eventually, you're going to run out of memory. You're going to run out of the ability to put more memory, or your physical memory constraints are going to get exhausted. So it's very important to kind of understand Spark memory tuning and really dive into the details of it. So this is a really important picture. If you're running large Spark jobs, you should kind of print this out and put it on your desk. Understanding this is key to managing your memory really well. So you have really 3 regions of memory that you should think about. It's the overhead memory, the Spark memory, and the normal memory. So the overhead memory is really where your compression codecs run. So if you're writing out a lot of files, your overhead memory will need to support that, because you're going to have a lot of compression running for writing out the files. So you set your overhead memory accordingly, depending on what your stage is doing. Normal memory is where your Scala UDFs run. Also, any kind of JSON parsing. So that's a very important thing for us, because we have a lot of JSON parsing that we do in some of the stages. So we need to provide a lot of normal memory for those kind of stages. And then Spark memory is really where everything else happens. All the meat and potatoes of Spark happen in that Spark memory. And the important thing to note is that there's a memory fraction that you can set, which basically partitions your JVM memory, where Spark can go all the way up to the memory fraction. But Spark will go greedily and try to consume everything in the memory fraction, whereas the normal memory is not really set up. So if you are doing a lot of JSON parsing, sometimes Spark will try to take up that memory, and you're going to have out-of-memory errors. So it's really important to balance these 3 regions of memory and be very cognitive of this. Another thing that sometimes gets overlooked is tuning the shuffle. So when you're working with a large job like this, where you have a lot of data and you're doing a lot of joins, you're going to run into a lot of shuffling. And tuning the shuffle is going to become key to being able to kind of run the job successfully and consistently. So this is just basically an anatomy of a shuffle where data from one stage to another stage gets streamed to different executors based on a hash key or any other key that you're trying to shuffle by. So like I said, it's often misunderstood and it's hard to debug. It's really hard to debug because you're going to get exception messages like this. Unable to register executor with external service, timeout exception, or the famous fetch failed exception. You're going to get things like this. And this is really, really difficult to kind of debug because these are really hidden underneath the covers. So what we've found is that Spark really has this external shuffle service. And if you're running these large workloads, your chances are that you're using this external shuffle service. And this external shuffle service can become a bottleneck many times. So you're going to have to tune this external shuffle service. And one of the key things, so just to give you a background, this shuffle service actually preserves the shuffle file so that if your executor dies after writing the shuffle, your shuffle files are still preserved so that anyone who needs those files can access that. This is a separate process from the executor, so it's a separate process outside of Spark. And that is key also because it manages its own resources. There are lots of tuning parameters for this. So I would encourage you to take a look at Shuffle more closely. And then really one of the things that really helped us was in Spark 2.3.2, they made the registration timeout configurable. And this caused us a lot of headache before this because basically the shuffle service was busy sending data across to a different node, and a new executor coming in trying to register itself with the shuffle service just timed out because the default is 5 seconds. So increasing this default helped us become more stable. The flip side to this is that if you have a very large timeout and your shuffle doesn't recover, your jobs are going to take longer to fail. So it's also kind of a double-edged sword. But in general, this has helped us out quite a bit. So these are some of the things that we did from a tuning perspective. So now we have all this data, right? What do we do with it? Show me the data, right? You've built all this data. So this is a scatter chart of 1 million points across 2 dimensions. It's not very helpful. As you get so many data points, you're going to find that plotting it becomes increasingly difficult. You can't just plot everything. You have to do some tidying up, right? You have to think about how to aggregate this data, how to package it nicely so that it can be analyzed and presented on a UI or to analytic users. So that's where summarization comes in. You could think that we can look at means and standard deviations of the data set, general descriptive statistics. But if you know about the Anscombe's quartet, these 4 data sets actually have the same mean, standard deviation, and correlation. But they are really different data sets. So these kinds of summarization metrics are not very useful when you're looking at different dimensions and high dimensionality. We need something else. We need to be able to do this in a more interesting way. So that's where sketch strings come in. And sketch strings are really a way of summarizing data in a way that you have millions of data points packed into a compressed data structure, which lets you query this data structure and get any quartile arbitrarily. And it gives you an estimated answer. And the estimated answer is, depending on which algorithm you use for the sketch string, there's a different kind of error rate on there. But in general, this is how it looks. So you have your raw data stream coming in, and then you choose some sort of time window, and you package that set of points into a set of sketch strings. And you store those instead of storing all the data. The sketch strings are a lot less in terms of data volume. You can compress it. You can combine them even. So you can aggregate these sketch strings over these dimensions and then query for these quartiles. So what do these sketch strings give us in practice? So, this is one of the things that I showed earlier, which was the country, app launch times by country. So this is a query in Druid, which you can just combine by country. So this data set actually has 29 dimensions in the background, but we are only aggregating across one dimension, which is country. And we are asking for a certain set of probabilities in the distribution. And if we run this query in Druid on the sketch strings, we get a really nice quantile array answer. And then you can go ahead and visualize the data in this way, where you can say that country A, B, and all these countries have kind of the same median load times, but country B really has a larger IQR. And actually, in this example, country A is the United States, country B is India in this case. And the median load times in India seem to be pretty much the same as the United States for this particular case. But you can see that on the right-hand side of this, you're going to get into a lot worse performance where you don't have good networks doing behind this. So really, that's in a nutshell what we've done with the data. I would encourage you to continue your journey. Visit us at jobs.netflix.com. We have a team blog, as Jitendra mentioned. I would encourage you to check that out. And obviously, we have open roles. We're always looking for people to join us. We also have a few more talks. I would encourage you to go to those. We have a security and detection platform talk at 2:40 and a personalization talk at 4:40. With that, we'll leave some time for questions.
Does anyone have any questions?
So you mentioned like you guys had some pain points with the external shuffle service. Wanted to know how do you play with the dynamic allocation of Spark and scaling up your clusters kind of things. What were your best practices around that?
Yeah, so dynamic allocation needs to be turned on in order for external shuffle service to be available. Right. So actually, if you increase the number of executors, you're going to put more and more pressure on your external shuffle service. And that's really the reason why the timeout really helps us. Because as you have more and more executors, there's more load, and the shuffle service is going to take longer to respond to you. And that's why that timeout really helps us. So as we scaled up, that's really one of the settings that helped us get out of trouble.
You have an interesting chart of applications, meaning you're using Flink. Normally companies, when you choose Flink, you stay with the Flink or you stay with the Spark, but you have mix. Can you come into details why you choose that architecture?
That's a very good question, actually. We asked that question ourselves. I think we saw a lot of potential in Flink. We really think that that's going to be the streaming platform that we want to invest in. I think Spark streaming would have been a good option as well, but we basically made a choice because we liked the direction that Flink was going in, and we kind of put our weight behind it, so to speak. I don't think there's a right or wrong answer there. It's just what we have adopted, and we are trying to scale it up.
All right, I have a question about the previous part of that architecture, which is the Kafka. What were the trade-offs and decision points in terms of choosing to have a Kafka that you manage and customize versus choosing a managed Kafka?
That's a very good question. I think, do you want to?
I don't have also a good answer, but we can actually get you an answer.
Yeah. Sorry.
Why Druid?
Why Druid? That's a good question. So Druid allows us to write custom aggregation libraries. And the sketch string that I mentioned, we have a Netflix histogram library that we have written, which we are hoping to open source at some point, which we built into Druid, basically. So you saw that query that I had. It was just a simple aggregation query. And in the background, Druid knows that this is a sketch string and how to aggregate it. So that's really the reason. And also, it can handle hundreds of millions of data points and do this aggregation very quickly. So that was really our reason to use Druid.
Which supports the interactive visualization because it's very difficult to curate all these data sets across all dimensions.
good question. So right now, we are doing this on a daily cadence. We have run pilots to do this on an hourly basis as well. But I think where we are moving is more real time. So we are going to push more of this architecture into the Flink piece that you saw, where we're going to build up more of the logic into Flink and land the data directly into Druid from there.
Yeah, actually, I follow pretty much the same question. Is why, if you like Flink, why you still keep Spark? Why you don't move everything to
Yeah.
Flink? Yeah.
So Flink came about, at least at Netflix, we started really heavily investing in it about a year back. And we had started this application performance metrics project much before that. And that's why that's why it exists in Spark. I think we were planning to go the Spark streaming route, but as we started adopting Flink, and more teams are using Flink, some of our producer teams are using Flink, we're kind of also going in that direction.
Hello. You did mention about earlier about the low power Android device and some of the high-end devices. I'm just curious to know, like, how complex it can get for you guys to understand that there are so many new devices coming in every day, and then how do you, like, architecture that? Maybe I know it may be a big topic, but just want.
Yeah, it's actually a very big topic. It's a really good question. Device segmentation is a huge challenge for us. You can't kind of segment the device based on memory alone, let's say, because a 2 gig Android device, all 2 gig Android devices are not the same. They're not going to give you the same kind of performance. A Samsung device is typically more well-engineered, and you're going to get better performance from a 2 gig Samsung device as opposed to, let's say, a 2 gig Oppo device. So it's a work in progress, I would say. We are looking at other dimensions in the device, like CPU, also real-time utilization data during the app interaction to kind of segment that. But yeah, it's a good challenge to kind of work on.
You said that you use the repartition as a way to resolve skew, but I don't think the skew itself is a problem. I think there is a problem when using join after skew.
Yes,
So
that's
just the case. I think you can resolve skew using broadcast dash join without repartition, because repartition using shuffle saw, I think, slowly performance.
that's a good point. I think the reason why I mentioned repartition was mainly because so obviously repartitioning is kind of the last resort, but in many cases, when you do the join, the broadcast hash join obviously will work for you, but if you repartition with the correct keys after your filter stage, you end up in a much better state when you're doing the join. And that's more like white gloving the data through Spark rather than letting Spark handle it. We've found that if we understand how the joins are going to work in the next stages, preparing the data ahead of time and taking that hit ahead of time sometimes actually helps with the performance down the line.
Hi, great talk, thank you.
Thank you.
I had a question about how do you segment, how big are your segments in Druid? So Druid has like recommendations as to like how big, how do you size that?
So our segments are about 20 gigs each. I don't particularly know why we chose that, because we have another team that deals with Druid. So I would, just for knowledge sharing, I would say it's about 20 gigs per segment. And we are putting data in there hourly in some cases.
I have a few more questions about Druid. Druid also have its own extension, its own sketch extension, which is based on Yahoo sketch library as well. So I'm curious why that Netflix decided to develop their own extension.
So we piloted the Yahoo library as well from Druid, but the error rate that we were getting in the estimation was higher than the library that we chose ultimately, which was the T-Digest library from Ted Dunning. We are looking into new sketch string implementations. There's a Moments sketch string implementation from a Stanford research paper recently. That looks very promising. So, I could include the links for that in the presentation.
Hi, I have a question about between Flink and Spark. when you stream the data to Spark, do you store in a Kafka or do you directly put into Spark?
So we land the data in various places. So the Kafka infrastructure that I talked about is not just one Kafka, it's a fronting Kafka, there's a router, and then from the router, the data can go into either S3, it can go into Flink, or it can go into another Kafka stream from there. So depending on the use case, there can be multiple streams. And the data set that I talked about is so key that it pretty much goes into every sink that we have, various slices of the data.
Hello. My question is, I saw you mentioned the podcast join. So this is for small table to join the big table. So if the two big table join, so how's your solution?
Yes, so that's the thing that I was saying, that when you're going to join two big tables, the more that you prepare the data ahead of time, the more that you know about what keys you're going to use and what kind of skew you have in the data is going to help you. So the way we solved it is by doing a forced repartition after the filter and projection stage to prepare it. Pardon me? Yeah. Yeah, so we have considered splitting out our pipeline by source. So like everything Android, we process that separately. Everything TV UI, we process that separately. So that's an option, but we haven't had to do that yet. But if we get to that stage, we will split it out that way. So we'll have 4 parallel processes just processing different sets of the data.
Just a question, actually, back to device. How much logic, I mean, you said you have some schema defined, so all the devices try to follow the same schema.
Yes.
How much logic you need to put in the device to enforce this kind of schema, common schema, versus how much you put the logic in your backend?
Yeah, so all the device platforms have a base logging library that just exposes an interface for the engineers to use. That this is the event that's happening in the UI. So it abstracts away the basic schema structure and how the logs are sent and structured from the UI engineers. So we work with the teams who build the base libraries to enable them to conform to the schema, but also give the UI engineers an abstracted kind of interface that they don't have to actually know about the schema at all.
Hi. Regarding schema, have you used Confluent's Kafka, schema binding and all?
We are exploring schema in Kafka right now, but we haven't. In this architecture, we don't enforce schema in Kafka.
Hi, thank you for the wonderful session. I have a question on the Kafka part of the architecture. So how do you guys handle late events in this architecture?
Late events?
Yeah.
That's a very good question. We have a lot of late events because people are on different types of networks. Sometimes we will hold back sending logs back because someone is on a mobile device network where they are not there's not enough bandwidth to send the data, or they lose the connection or something. So there's a lot of late arriving data. We don't handle it on the Kafka side right now. We just stream the data through, and we handle it after the fact on the analytics side. So right now we're doing daily or hourly aggregations, which kind of helps us catch most of it. But then there's always that bucket where you have late arriving data, and we kind of throw that into its own separate bucket and we analyze it separately. Yeah. So actually the late arriving data is of more value in some cases because those are the cases where the application did not perform well or the network didn't perform well. So we really take a hard look at the late arriving data, and that's why it's kind of separated out.
Maybe you have time for one last question.
One last question, all right.
Did you ever have a chance to look at AWS Glue? That's the managed Spark. I mean, I don't know. I know that the scale you're on is like a very different scale, but I mean, any experimentation over there? Have you tried AWS Glue as a managed Spark service?
I'm not aware of us using AWS Glue.
We generally don't leverage managed services. So our cloud is all built on their just on metal and bare pipe. So everything else is on top we have built ourselves. And you touched upon it, it's because of the scale and complexity of our architecture. We have to really go deep into it so we can optimize it, and it integrates well with existing infrastructure. So we have absolutely I don't have any understanding that we use managed services anywhere in our infrastructure.
All right. Thank you, everyone.
Thank you.
Quick note to rate the session.